So, once again, lesson 2-1 and 2-2 is about using mental math and estimation. So, we're going to go ahead and write that mental math and estimation. And when we're talking about using mental math and estimation, all it really translates to is making the numbers easy for us to add. So when we have something like 142, and we're going to put it in terms of dollars because those are nice and easy to understand, 142 and maybe 258, we can use mental math here to help us add these up. Now, looking at some number like this, I can go ahead and say, well, $1.42 kind of is close to $1.40. And I can say that $2.58 is pretty close to $2.60 because I know that $1.42 is only 2 cents away from $1.40, and I know that $2.58 is only 2 cents away from 2.60. So I, in turn, made these numbers pretty easy for me to add because otherwise I would have to sit there and kind of write out 142 plus 258. And I know that 8 plus 2 is 10, 5 plus 4 plus 1 is 10, regroup, and then we have a 4. So we have $4 there. Well, I know that 60 cents plus 40 cents in my head is a dollar. And I know that $2 plus $1 is $3. So if I had 3 whole dollars and then I had a dollar worth of cents, altogether that gave me $4. And that's where the mental math and estimation comes into play. Today, when you work on your math, you're going to be doing a lot of work where you're sitting there going, oh, this costs $5.99, this costs $6.49, this item costs $7.29, this item costs $8.63. I'm just going to pick up some more weird random numbers. $10.27, $5 and let's say 86 cents, and then throw in $9.99. When you go shopping, you don't always have your calculator out. You don't stand there and go, 5.99 plus 6.49 plus 7.29 plus 8.63 plus 10.27 plus 5.86 plus 9.99. Let's say we bought a bunch of items for all these prices. So we bought something for 5.99, and logically I'm going to sit there and go, well, 5.99 is about $6. So I estimated 5.99 to the closest dollar. 6.49, I'm going to say, well, 6.49 is kind of close to $6.50. So I estimated that one to the closest half dollar. 7.29, I can say, well, 7.29 is kind of close to 7.50. It's only 21 cents away from 7.50 versus 29 cents away from $7. So I'm going to round 7.29, I'm going to estimate it to about 7.50. 8.63, I can also think about. 8.63 is pretty close to 8.50. It's also close to $9, but it's definitely closer to $8.50 because it's only 13 cents away from 8.50 versus 37 cents away from $9. So right away, I can see that $6 is definitely easier to add. 6.50 is easy to add, 7.50 is easy to add, 8.50 is also easy to add. And the reason we use half dollars is because 50 cents plus 50 cents is super easy to add. So we can say 50 cents plus 50 cents is going to give us another dollar. Let's go ahead and finish estimating the rest of these numbers. Now, 10.27 is pretty close to 10.50. It's 23 cents away from 10.50 versus 27 cents away from $10. 5.86 I can say is pretty close to $6. And then 9.99 is very obviously close to $10. And using this technique of rounding to the nearest dollar or half dollar, I make these numbers really easy for me to add in my head. So once I'm shopping, I can go, well, I can add these dollars first. 6 plus 6 is 12. Plus 7 more is 19, plus 8 more is 27, plus 10 is 37, plus another 6 is 43, plus another 10 is 53. So that's about $53, and I see that I have these two 50 cents that make another dollar, so that's $54, and then two more 50 cents that I can put together, and that's going to be about $55. So using smart estimates, I can say that I'm about to pay $55 at the very least for my purchase. Now, sometimes it doesn't make sense for us to only round to half dollars. When we have weird numbers where it was like 1063 or maybe like 527 or 789, these are all very strange numbers to use when we're rounding to like a close half dollar. Sometimes it makes sense to just round to the closest 10 cents. So when I'm looking at something like 1063, it's very safe for me to say this is pretty close to $10.60. I can look at something like $5.27 and I can say this is pretty close to $5.30. And then I can also look at a number like $7.89 and say, well, this is pretty close to $7.90. And it's important that we also know how to round to the nearest 10 cents because it's easy for us to add 10 cents as well. Because all we have to now think about is 60 cents plus 30 cents. Well, that's 90 cents. And if I add 90 cents with 90 cents, that's $1.80. So I can say $1.80 plus $10, so we're at $11.80, plus another 5, which is going to be, I lost count. Let's go ahead and write that down. Like a good mathematician should. We should write down numbers. Let's add our dollars first. $10 plus $5 plus $7 is going to be $22. So it's always easier to add your dollars first. And then we take care of the cents. And we see it's going to be 90 cents plus 90 cents, and that's going to be $1.80. And I know $1.80 plus $22 is going to be $23.80. So we know that when we pay this price right here, it should be pretty close to $23.80. Let's go ahead and test that out. I'm going to add these three numbers, if I can squeeze it in here. And we're going to have 3 plus 7 is 10, plus 9 is 19. Regroup that 1. 8 plus 2 is 10, plus 6 is 16, plus 1 more is 17. 7 plus 5 is 12, plus 1 is 13. And then 1 plus 1 is 2. So $23.79. And I can see that my estimate was actually really close to the actual price that I'm about to pay.